Students, 1 joule is the work done by a force of 1 Newton when a body moves through a distance of 1 meter in the direction of the force. In CGS, C stands for centimeter, G stands for gram, and S stands for second units. And the unit of work is ERG or erg. Now, 1 ERG is the work done by a force of 1 dyne when the body moves through a distance of 1 centimeter in the direction of force. Now, look at the following examples. The first example says, if a man lifts a box of 5 kg mass to a height of 2 meter, calculate the work done by the man, where the value of G is given as 9.8 meter per second square. Students, here is the solution. Here, the mass of the box, that is M, is equal to 5 kg. The acceleration due to gravity, that is G, is equal to 9.8 meter per second square. The distance, that is D, is equal to 2 meter. And now we have to calculate the force, that is F. Now we know that F is equal to the product of mass and acceleration due to gravity. So we write 5 into 9.8 is equal to 49 Newton. Again, we have the relation work is equal to the product of force into distance. So we write W is equal to F into D, which is equal to 49 into 2. That gives us 98 joules. Therefore, the work done by the man is 98 joules. Now look at this example. It says, a bullock cart is pulled through a distance of 10 meter when a force of 500 Newton is applied. Now calculate the work done on the cart. Let us solve for this. Students, here we have been given force applied, that is F, as equal to 500 Newton. Distance, that is D, is equal to 10 meter. And the work, that is W, is to be calculated. Now we know the relation W is equal to F into D, which equals 500 Newton into 10 meter. That gives us 5000 joules as the answer. Therefore, the work done on the cart is 5000 joules. Now let us move on to another example. Look at the question first. It says, a laborer raises a 2 kg brick pile to a height of 2 meter. Calculate the work done on the brick. Now look at the solution. Students, here force has to be calculated. The weight of the body is the force and the man works against the gravity. And we have F is equal to mg. That equals 2 kg into 9.8 meter per second square, which gives us 19.6 Newton. Now, after calculating the force, let us calculate the work done. We have the relation W is equal to F into D. Now let us substitute the values. And we write W is equal to 19.6 into 2, which is equal to 39.2 joules. Therefore, the work done on the brick is 39.2 joules. Students, as defined, work can be performed by various bodies. The work done by a body can be explained in the following ways. For this, let us look at some activities. Work done by a lifted body. You know that you can push nails with the help of a hammer. The hammer hits on the nail and the nail passes in. The force is applied with the hammer through a distance on the nail and the nail passes in. This shows the work is done by a lifted body. It shows you the work done by stretched rubber. Students, consider that you have tied a small stone ball at the end of a rubber band. Stretch the rubber band to some extent and release it. As you release, the stone ball goes to the original position. Here, force is applied to pull the rubber through a certain distance, which can do some work.